And our first speaker is Cederic Lenz, a Senior Solution Architect. You can come up, Cederic, at TÜV-AI Lab. Please, a round of applause. Yeah, I can already put your timer here. You will introduce it yourself, but the TÜV-AI Lab is a joint venture of the TÜV organizations, TÜV Süd, TÜV Rhineland, TÜV North, TÜV Hessen, and TÜV Thuringia. And Cederic worked at a place very close to this venue, which is Fraunhofer. But not HHI, it was the Fraunhofer Institute for Mechatronic Systems Design, IEM. And also Cederic studied at a university close to my heart, because that's where I was raised, Paderborn, which, by the way, has the biggest computer museum in the world, also very interesting. And he focused on the application of hybrid modeling for anomaly detection and production data. And at the TÜV-AI Lab, he is involved in several projects, also safe AI engineering, trying to ensure that Germany does not turn into an industrial museum, but actually can pull this off to develop trustworthy AI. Over to you.
Yeah, thank you so much, Patrick, for the introduction. Well, very warm welcome for me as well. Very good morning to everybody. So yeah, as introduced, my name is Cederic Lenz. I'm working at the TÜV-AI Lab, and I'm happily kicking off today's first session titled Technical State of Play, Foundations of Auditing Trustworthy AI. Great. So let me give you a brief introduction of who we are at the TÜV-AI Lab. Well, we are an independent joint venture, and as Patrick mentioned, we are funded by 5 big TÜV companies, TÜV Süd, Nord, Rhineland, Hessen, and TÜV Thüringen. And our mission is to translate regulatory requirements into assessment practices. Okay, so let's talk a bit about basics. And what are our basics? It's the requirement of high-risk AI systems that is written down in the AI Act. And for those, or for us, it's four big groups. It's the technical criteria, then the introduced ethical criteria, a big field. Of course, there's documentation, such as technical documentation, logging, and so on. And then there's a huge system of management systems, meaning we have risk management systems that we need to audit, and we also need to audit quality management systems. Let me shed a bit of light also into the conformity assessment process, I mean the overall process, which consists of 3 key elements. First off, there is the assessment of the quality management system, which involves more processes to be tested, and on the other hand side, on the product test side, there's the technical documentation that is being assessed. And kind of as a link in between, there's the assessment of risk management systems, where both perspectives are being placed into, so such as that these processes behind assessing what kind of risk do we have at the system under test, and also, of course, the risk that the product poses on its environment, its usage environment. And as you maybe know, as of Annex 7 in AI Act, there is the possibility to also go a bit more deeper down. In case of doubt, the assessing authority or the notified body is also empowered to carry out tests of the system itself, meaning like performance, robustness, cybersecurity, and so on. So we, as a notified body or as a maybe future notified body, need to be able to perform these tests as well. All right, so 3 key elements I want to shed a bit of light onto now. We have published a paper early this year about these 3 assessment criteria: performance, robustness, bias, and non-discrimination. And there, just the outcome of the paper was that it's kind of hard to automate testing and assessment of these 3 major criteria, and therefore, like our statement was, well, the technical assessment needs domain expertise because it's so hard to automate these tests. And speaking of domain expertise, we need to gain domain expertise, and our processes behind means that we have now developed 3 main products ourselves, which is first the AI assessment metrics, the AI system taxonomy, and the TÜV AI assessment framework. We've covered the AI assessment metrics in last year's talks quite a lot already, and for those who had been here yesterday at the AI Con, we have also been talking about the TÜV AI assessment framework. To those who have missed it, it was held by my colleague Christoph Pötsch. Please feel free to catch up with him during the day, as it's a big new product of ours and a big new topic, so a lot to speak and discuss about. But what I want to do now is that I want to shed light on our TÜV AI system taxonomy, which hasn't been spoken about. I mean, we've published it on LinkedIn as well, but I don't think we have had a talk about this already. So what does it consist of? Well, there are 3 main elements. It's the task, the input, and the implementation of an AI system. The task questions, what does the AI system actually do? The input, on what basis does the AI system do what it does? Well, and maybe how it was trained on. And thirdly, the implementation questions, how does the AI system do what it does? So the underlying algorithms, the architecture, and so on. I will go through this now in detail. Let's talk about task. What information does give us the information about the task? Well, it helps us understanding the behavior of the system. It helps us choosing the appropriate testing methods, and of course, building scalable evaluation strategies on these specific tasks. What might be a task? We have identified around 10, so I mean exactly 10 different tasks, which is identification, labeling, clustering, future state prediction, and 6 more: ranking, regression, retrieval, segmentation, and 2 different generation tasks. It's the creation or the transformation. And next to the task, we also have the input. There we structure, or we classify on the shape of the input, basically. So it's ranging from images, 2D, 3D, audio data, video data, onto structured data, and lastly multimedia data as well. So all you can think of, you can put into an AI system. And the third one is then the implementation. And now what I really enjoy here is that we really break down the big buzzword of AI into something more tangible. And now we don't speak about it at all as a whole, AI, but we then speak about maybe clustering algorithms, mathematical optimization. We have now been hearing a bit about decision trees, regression analysis, and everything you can think of, or you are maybe working on when you are a scientist on AI systems. So I know this might not be the full range, as AI is developing so fast. There might be a new one coming up, and so of course we need to keep up with the state of the art when developing and maintaining our system here. And to maybe give a bit or make it a bit broader, let's look at the central one, the neural networks. There's a huge variety of neural networks out in the market, but yet we have managed to make it categorizable. So you see here different neural network-based systems, feed-forward, convolutional networks, recurrent, and of course, maybe there might be mixtures of both. So me personally, I've worked with recurrent convolutional networks, all you can think of. But our current statement is that we have covered the state of the art of AI systems within this slide. So maybe you can challenge us in later stages if you don't see yourself here in the slide. So our main statement here is that the AI system taxonomy now is the foundation for us for type-specific assessment and gives us a clear idea of what we are testing there. All right, so now again, the path from classification to conformity. We have covered AI assessment metrics, AI system taxonomy, and AI assessment framework, but how do they actually belong together? Maybe let's shed light on this. The AI assessment metrics gives us a deep understanding of what the requirements are, like what dimension, what life cycle step is involved, and what testing layer is involved there. So it's like the testing space we see. The TÜV AI system taxonomy, on the other hand side, gives us a clear idea of what type of system we have. As I said, we don't talk about AI anymore. We talk about a clear specific type that we are testing now. And all this coming together in this TÜV AI assessment framework now gives us the ability to really have a tailored process, a tailored audit pipeline for that specific AI system that we have under test. All right. I guess, yeah, that's all from me. Thank you so much. I'm delighted to talk to you now or maybe also later in the in-between sessions. Thank you so much.
Thank you so much, Cederic. Let's have at least one question for each speaker and then merrily mingle more in the coffee and lunch breaks, because we are here in this room. Of course, this is something you don't get online. But are there any questions for Cederic? Ibrahim again, you were already? Maybe if there's someone else? No?
One more time. So, thanks, Cederic. Thank you. How does this relate to these newly proposed codes in the Annex 14? How do you see this working together?
Maybe a bit speaking up.
So you were talking about the system taxonomy, right? And in the newly proposed omnibus, there was these codes proposed. So the AI-specific technology codes. How do you see this relating to that?
Well, I guess it was yesterday in the more political panel we had here that there are codes for being notified as an assessor of different systems to those who have not been part of it. And there are so many different codes that you need to apply or get notified for a diverse range of AI system. It kind of matches when I talk about system taxonomy. I don't want to talk about AI as a whole anymore. I want to be type specific because, I mean, this is the way to go. For us, our statement is that it makes things a bit more complicated when dealing with notification processes. It's all behind it, but I will see that we will need to deal with it. Maybe it's getting a bit more, it's not yet decided, but maybe they will have changes on this as well. I guess we as a TÜV-Universum will need to deal with it a lot.
Great, thank you, Cederic. And yeah, great question, also great progress. Thank you very much. Let's applause again.